Now, just a little note here. We often talk about p-values, and we might think those are measuring the effect size. But in actuality, those are measuring the sample size. You don't want to get confused. I'm going to go through some quick examples to try to remind. Now, we'd like to believe that we'd get clear results from our statistical tests. The comic XKCD, the favorite cartoon of geeks, has a cartoon about exactly this. Shows a famous graph about vaccine usefulness, which plots cases of COVID against time. There's the group that got the vaccine. There's the group that did not get a vaccine, instead got placebo. Those two groups, whoosh, completely diverged. The tagline is there. We reject the null hypothesis based on the hot damn check out that chart test. Now, it'd be nice if we had more results like that in the world, but unfortunately we don't. But the power of statistics is to try to extract some sense from the noise of the world. Now, of course, actually that graph is not really a statistics-free explanation. I mean, there's quite a lot of good work beforehand, like pre-registered data collection. Researchers said this is what we're going to be measuring even before they did the study. But we're not going to get too deep into that. Now, commonly we're going to get a p-value below chosen critical values such as 5%. We might believe such a p-value signals a case like these two distributions I've shown here. These two distributions have the mean that's really far apart. With a sample size of just 4, I can distinguish a difference in means this size at a p-value of 5%. Just 4 observations, I can certainly see some really huge effect sizes. But more commonly, I don't have 4 observations and a huge effect. Instead, I might have a p-value of 5%, but 100 observations. In that case, I can distinguish much smaller differences. These are standard normal distributions, and you can see the plus or minus 2 standard errors on the little X tick marks there. So, this is a pretty small size with 100 observations. With more observations, you can distinguish really, really small differences. Here I have 10,000 observations, and is there a difference? I can't really see it. Maybe if you squint really hard and put your nose against the computer screen, you might see a difference, but it's pretty small. That's just a reminder of the power of statistics, but also a reminder of the limitations of the power of statistics. A nice low p-value does not necessarily mean there's a big honking difference. It may mean there's a pretty small difference. Lots of companies do A/B tests where they put almost the same web page in front of different consumers, try to see if they make different choices to try to increase their revenue. Popular website, it's easy to generate tons of observations. So a p-value of 5% demonstrate that people prefer one layout or another. Those are tiny differences. Might not even be important in the real world. I mean, there's a separate question, are the differences important? A p-value does not tell you that these are important differences. Rather, it tells you that we can distinguish some differences if we want. In the world, p-values are used and abused. If you want to play with those yourself, here's the R code. You can see what you figure it out yourself.